Now what is the straight line equation? Y equals to mx plus c, right? If I am comparing equation 1 and 2, what I will have, y is equal to ic and m is equal to minus 1 upon rc and my x is vce. These are the terms which I have found from equation 1 and 2 after comparing, right? So on the y-axis I will have my ic, on x-axis I will have my vce, and the slope of the line joining the x and y-axis will be minus 1 upon rc. Now for the straight line, how we find maximum values? By putting the other value to be 0. So in case 1, what I am considering, when BGT is in cutoff region. Now if you are remembering the transfer characteristics we have drawn, here it was the cutoff region, here you had saturation region. So in cutoff region, what you can say, IC value is 0. On y-axis you have IC, x-axis you have VCE. So on the x-axis the value of y-axis will be 0. When BJT is in cutoff region, what you will have, the value of IC will be 0. So if value of IC is 0 and substituting in equation 1, what I will get? I will get VCC equals to VCE. How? If I am substituting IC is equal to 0, so the equation will be minus VCE upon RC plus VCC upon RC. So what I will have, VCC upon RC equals to VCE upon RC. RC will be cancelled and you will get VCE is equal to VCC. VC equals to 0, I will have IC equals to 0 plus VCC upon RC. So I will get IC maximum or saturation, you can call. Technically you should call it as IC in saturation region will be VCC upon RC. So I have got two values, VC is 0 and second is when IC is 0. When IC is 0, I got VCC as VCE. So these are the two values which will be the two maximum values in the DC characteristics. Coming to the load line, we have got two values, IC saturation and VCC. So VCE has maximum value when your IC is 0. So this is the condition when you have IC is 0, and this is the condition when you have your VCE to be 0. So you get IC saturation value we have found from the equation as VE upon RC. Now the slope of the line is minus 1 upon RC. So what you can say, since the slope is inversely proportional to what? To the DC load resistance RC, it is called as DC load line. Now is the concept clear? Why it is called a DC load line? The slope is inversely proportional to the DC resistance RC, hence it is called as DC load line. Now we have completed the DC load line. Now the next point is to find the Q point. How to find the Q point? See here, what is Q point? Q point is quiescent point, still point, or the other name for still point is again silent point, inactive point. Why we find Q point? Because at Q point, whatever waveform you are applying, it remains constant under DC operating conditions without AC signal applied. Under DC operating condition, the Q point remains stable. Now how to find the Q point is, you know the output characteristics of the BJT we have drawn. For output characteristics, you have output voltage on the x-axis and output current on the y-axis, right? And keeping input current constant, we had plot this graph for the characteristics. The same graph has been drawn over here with an overlapping of DC load line. This point is VCC and this point is IC saturation. So it is VCC upon RC. So you got 2 points. When you superimpose the DC load line on the output characteristics, wherever it intersects the DC load line, the point what you get is called as Q point, right? Now the position of the Q point varies. If it is at the center of the DC load line, we call the transistor is operating in the active region. If the Q point is towards the cutoff region, what we can say, the transistor is operating in the cutoff region. And if it is towards the saturation, here you have saturation region, here you have cutoff region, and at the center you have active region. If the Q point is moving upwards towards the saturation, then we call it as the transistor is operating in the saturation region. So Q point, what it does, it decides the region of operation of the transistor. So this is the concept of DC load line and the Q point.